Hello, welcome to an instructional video intended for industrial engineering students learning Calc 2, also known as Math 166 at Iowa State University. We're here today to address an uncertainty that you may have, or to answer one of the questions. For example, why am I learning about this stuff? Can I just memorize it, pass the exams, never worry about it again? Or how is it relevant in my future classes or future career? I understand that it can be difficult to be self-motivated when you're learning material that you don't know what it's going to be used for. So the goal of this video is to help you understand why integration is actually important, and also how it's used in junior and senior level classes. We'll provide a simple example from IE 341, which is a lean production class. This example also happens to be common in the workforce, and so try and stick with us because we are aware that you have not taken this class yet, but hopefully this helps.
The example used in IE 341 uses an equation that solves for the number of shortages that occur during a cycle, for instance, when a grocery store needs to restock its shelves. The equation for the expected shortages per cycle is the integral from r to infinity x minus r 1 over the square root of 2 pi sigma times e to the negative 1/2 x minus mu over sigma squared dx. To use this integral in a real-life situation, we must make some use substitutions. If we make a change of the variable x to the standard normal, also known as the z-score, where z is equal to x minus mu over sigma, we can rewrite the equation for the expected shortages per cycle as the integral from r minus mu over sigma to infinity mu plus z sigma minus r times 1 over the square root of 2 pi sigma e to the negative 1/2 z squared sigma dz. When simplifying again, we can make another use substitution where phi of z is equal to 1 over the square root of 2 pi sigma times e to the negative 1/2 z squared sigma. The equation for the expected shortages per cycle can then be written as the integral from r minus mu over sigma to infinity z sigma minus r minus mu phi of z dz. Simplifying once more, we can write the expected shortages per cycle as the following equation. The integral from r minus mu over sigma to infinity z minus r minus mu over sigma phi of z dz times sigma. From our derived equation for the expected shortages per cycle, the equation for the unit normal linear loss is expressed as L of k is equal to the integral from k to infinity of z minus k times phi of z dz, where k in this case is equal to r minus mu over sigma. We can then write the equation for the expected shortages per cycle as equal to sigma times L of r minus mu over sigma. In the example problem, we need to find the optimal inventory policy. we are given the following variables. The mean lead time demand, known as mu, is equal to 80 units. The standard deviation, sigma, is equal to 4. Demand is equal to 40 units per week. Availability, A, is equal to 50. The shortage cost, also known as pi, is equal to $5, and the holding cost, known as H, is equal to 0.0225 cents per week. In order to focus on the integral we derived, we will skip initial equations and go straight to the reorder point. The reorder point is equal to 86.68 units. Rounding up, we can get that to equal 87 units. Solving for the expected shortages per cycle with this given value, we get a standard deviation, also known as sigma, of 4 times L of 86.68 minus 80 all over 4. This turns out to be 4 times L of 1.67. To solve for L of 1.67, the table for the unit normal linear loss is located, and the indicated value that is under L of 1.67 is 0.01967. Using this number, we plug it back into the equation to then get 4 times 0.01967 equal to 0.0788. From here, we can calculate the optimal order quantity, also known as Q. This is equal to the square root of 2D times A plus the shortage cost times the expected shortages per cycle all over the holding costs. Working through this calculation, the optimal order quantity is 423 units. With R being equal to roughly 87 units, and the optimal order quantity of Q equaling 423 units, we can conclude that when the inventory level drops to 87 units, you should order 423 more units.
Hey, I hope that video was beneficial to you. That was just one of the many encounters that you will have with integration from Calc 2 in your future. Just to mention a few applications where you might see integration after graduation. One, any production or supply chain system. You'll need to use integration in those cases. Also when monitoring inventory and restock levels. You also need to apply your knowledge of integration in those scenarios too. Just to wrap up the video today, a few things to take away. Integration is important even after Math 166. Memorizing may get you past the class right now, but it will definitely hurt you in the future. And for you taking that class right now, and trust me, I was there, it can be difficult to see the value in this material, but it would be wise of you not to blow it off. Well, thank you for watching the video. Good luck in your classes and enjoy your adventure.